Okay, so grab a beer or 6 and then follow along. We're going to just go through the code of what happens with section control. And of course the whole purpose, you can't talk about everything in one video, but the whole purpose of AgOpenGPS is to get new GPS information. And then when you get an updated fix, then you go through and do an entire frame. You do the section control and you do look ahead and follow the line. You do all of those things. So in the background, the GUI triggers every 15 milliseconds, 10, 15 milliseconds, and goes and checks if there's any new data. Is there a complete sentence? And if there is a new sentence, well, then we kick off and do a complete frame. And first thing we do is we start and stop a frame counter, so we know that's that number up at the top. We know how long a frame takes. So by the time it gets back to here, that's exactly how long it takes to do an entire frame. So now we've got our new data, our new heading, and our new speed, and all that sort of thing. That's all come in on a valid NMEA sentence. So the first thing we do is we go to update fixed position. Now what this does is it takes our current position and it updates what our new one is. So it's all about the current fix and We'll go fairly quickly through this. This is that array that makes sure that you exceed a certain distance. Make sure you go like at least a meter before you actually update the distance. And what this is it's a 60 position array, and it just keeps track of all the little values. And then once all those little values exceed a meter, then you've moved a position. Otherwise, it moves around back and forth, and the heading will change, and it makes the thing spin round and round and round. Well, that's no good. If you're sitting still, the GPS is still, as you know, wiggling back and forth. So the whole part of step fix is to keep your position still, not change the heading, not change anything, even though the GPS is moving around. So that's a critical piece of software. And if it has changed, now, or if we're in a new position and the thing has actually moved, then we do all our calculations and section control and that sort of thing. So the first thing we do is calculate our position and heading, which is down here. So here we check what kind of heading. Are we getting it from a fix, like a fix-to-fix position? Are we getting it from GPS, which is the true heading? Or are we getting it from dual? And then we make those settings accordingly. And then if it's the simulator, we just set it to true. Now, in terms of correction with the IMU, then all of this gymnastics math here, that gets around the fact that you go from 360 to 0, or 360 is 0, so you can't just linearly average two headings together, because 359 and 1 are only 2 degrees apart, but they're actually 357 degrees apart. So that's what this math does, and this just keeps aligning the IMU closer and closer together with the actual GPS heading. None of that is used if it's using dual heading. And then we calculate the steer angle position, and where's the tool, and the trailing of the tool, and what's the heading of the tool. As you go around with a swinging drawbar, the tool heading is different than the vehicle heading. So that's what all this tool position does, is it figures out where that tool is. And if you're using 2 hitches, well, then it's a hitch and then a hitch. And so then you can have 2 bending moments between the vehicle and the tool. And so that calculates all of that. Then what we do is we don't want to plot, when we're going straight out, we don't want to plot a new triangle every fix. So if you're going straight, that means we can really cut down on the number of triangles that we plot. And that's what this does. It takes our left and right speed of the tool, and it figures out which one's going faster, and then it just, if you're going around a corner, one is going to be faster than the other side, left side's going to be faster than right side, and vice versa. So this just calculates what that spacing would be based on how quickly you're turning around the corner. If you're going faster around a corner, or sorry, if you're making a sharper corner, you need more points for when you're doing the contour. And that's all this does. It speeds up or slows down how quickly this section trigger step distance is. The shorter the distance, the more often it'll make those little triangle boxes. And then we calculate the section heading of the tool and that sort of thing. Okay, now we're back up at here. Then we do calculate section look ahead. Now this is the busy one now with section control. And so what do? Remember that there's 10 centimeters per pixel. Remember we were talking about the BackBuffer. That's all very important. So then everything is 10 times both speed and position, that sort of thing, when we're talking about the BackBuffer and pixels and that sort of thing. So you have to kind of decide whether you want to do actual speed or pixel speed. And it's easier to work in a single unit. So a lot of this stuff is going to be multiplied up to being so many centimeters per pixel. In this case, it's 10 centimeters per pixel, which just is 10 is easy to use. So now, first thing we have to do is we have to figure out in each of those individual sections, remember some can be going backwards, some can be going forwards, that sort of thing. We need to figure out what the speed of that individual section is. So, when we're calculating all the individual sections, the first one, we calculate the first left point. And that's only on the very first section. And then we can calculate the right point. So once we have the calculation for the first left side and the right side for the first section, then the right side of the first section is now the left side of the next section, because it's the same position, because they're sitting right side by side. So that's all this does, is it takes the length of the last position that the section was in. We looked at 2 x's on the previous video, and we're measuring the length of that over how long. Like it's 10 updates per second, and then remember it's our 10 is our pixels per second, and that gives us a meters per pixel, or meter per second per pixel. Whew. But it's just a speed, it's just like meters per second times 10 pixels per second, or 10 centimeters per pixel gives us this value. So if it was a frame of 5, you'd multiply by 50. If it's a frame rate of 100 milliseconds, then it would be, this is 100. So this just gives you the speed in pixels. And it sounds crazy, but it works. So then we calculate the right speed, and we calculate the left speed for each and every section. This goes through all the different sections. So if there are 16 sections, it does all this 16 times. But if we can use the right calculation and flip it over to the left side and then just use that for the next section, then that saves us half the calculations right there. So here, and then this is just how fast is the right side going. And now we just figure out, and this is just a careful way of using pi and half pi to figure out, are you going backwards or are you going forwards? I'm not going to bother explaining that. You can look at it and then look it up. It's a very handy way of using pi and headings. So now we just save the tool speed, and remember we have to pick the fastest speed for that section. So we just pick the fastest section or edge of the tool speed, and we save that. So now we've got our left speed and our right speed and our position. Phew. Okay, now we filled in the tool positions. And how fast is the outer part of the tool going? And the left side and the right side of the tool itself, like of the super section, the one where all the sections are on. And we can just steal that from the left point of the first section to the right point of the last section. And then now we do our look aheads. Because we have a speed, and because we have our look ahead time, say 2 seconds, and we're going 2 meters per second, just like in that last video, that gives us a look ahead distance. Again, in pixels. Everything's in pixels per second, so it's just multiplied by 10. So 200 is actually 20 meters, but it's 200 pixels. When we look 200 pixels ahead, we've gone 20 meters, and that becomes our look ahead. So we have it for our hydraulic lift, and then we have the left and right side of the tool, and we know how fast it's going. We can calculate how fast the inside of the tool is going because we know how fast the right and left side are going. And of course, we have to keep track of the headland. And so, where are the tool corners? Well, let's go to that definition. So the first thing we have to do is figure out is the left side and the right side of every section, are they inside or outside of the headland? That's that circle. And a function called isPoint in head area, that determines whether or not that left point or right point is inside the headland. And for every section, it knows if that section is in or out of the headland. So again, that does that for every section. It figures out exactly where it is, because you got to know where the thing is, or you can't do it. And then you set up for section for U-turns and that sort of thing. Set the boundary. Is it in the boundary? Is it out of the boundary? Same as with the headland. So you have to go check them all for the boundaries, and then that's what this does. Is the point inside the boundary now? Is it inside the boundary or outside the boundary? If it's outside the boundary, you want to shut the section off. So again, for every section, it has to do, is it inside the boundary or is it outside the boundary? So then we record all of those things. And then we, same sort of thing, we can use the left side for the right side. And then we go back. Okay, now let's go back up again. Okay, now we're back here. Now we've done the section look ahead. We know what our trigger distance is from our previous section position. Now we check on whether or not it's time to do a trigger, because remember we calculated that based on the speed of the outer part of the section. So now we go to add section contour path points. And then in here is recording on, like for recorded path, and we figure out what kind of recording we want to do. Is the curve on? Is the AB line on? Is contour on? That sort of thing. And we just save the position. That one's pretty easy. All right. And then this is okay to add points. And when we're driving around and we're creating a boundary, then the same sort of thing. We just take our current position and create a bunch of points with it. Okay, so now that part is done. We have some of the calculations done. We kind of know where we are. But we haven't turned on any sections. We haven't done any mapping. We haven't done any of that yet. Because what's most important now is some of the other stuff, like doing all the auto steer calculations. Are we in or on one side of the line or the other? And we generate our error checks to send off the Arduino to control the steering. And here we do that. We send it out the auto steer port, or we send it a UDP message. And then we do all the U-turn stuff. Are we in and out of the bounds? Are we inside the geofence? We create the U-turn. Have we canceled the U-turn? Is it a valid? Are we too close? Are we out of bounds? All of those things happen with U-turn. And then all the remote switches stuff. Here's Matthias's switch stuff. And did somebody move a switch one way or the other? So then you have to go through all the switches, through all 16 sections, and determine whether or not somebody clicked the switch and turn them on or off accordingly. And that's just a bunch of repetitive code. Once you make one, it's the same for the rest. And then we're done. Well, kind of done. Then what we do is, I'm not going to talk about it, but we refresh the main image, the main picture on the main OpenGL screen. And then when that is done, it goes and requests, we'll move this over. What it does is at the end of painting the main screen, it now asks to paint the BackBuffer. So just like painting the back, remember we saw the little BackBuffer picture? We're just drawing the same sort of thing except really zoomed in tight. We load identity, that means we back the camera up so that we know that it's 50 meters across, again, 50 meters, and it's 500 pixels. There's that magic 10 per pixel. So and then we set the right color, and our patch color becomes half green. So it's like 127 out of 255 green. So all our patches are that one color. And then we calculate our frustum, which is that, like looking in a mailbox and looking at our screen, what's inside, what's outside of that screen. And whether if it's outside, we don't draw it. If it is, then we draw it. And that's all pretty simple. And then we draw the boundary array, or we draw the boundary on that screen, and we draw it at 240 instead of 50. Just so that it's a different color, we can distinguish then by the color stored in that pixel whether or not it's a boundary or whether it's a section. And it's the same thing we do with the headland. We draw the headland around and it becomes 250. So we can differentiate then between a boundary at 240 and a headland, which is at 250. And then flush, what this does is it then just spits it out. It puts that information into memory. Now we don't swap this and make it visible to the user because all we're doing is writing to the memory because we're going to be reading the memory again. All right, this over a little bit more. And it gets into the nitty gritty here. So remember that look ahead. What we want to do is the vehicle lift look ahead bigger than the look ahead distance on of the tool. So we're just trying to find the maximum amount of look ahead so that we can minimize the size of the buffer that we're looking at. We have to go as wide as the tool, but it depends how far we're looking ahead to determine how much buffer array there is. The bigger the buffer, the longer it takes. So we kind of want to minimize that. You don't want to just add everything together and take the maximum out. So we have a read pixel buffer, its height, and then we have the on height, which is the farthest one ahead in terms of section, and then we have the tool height, which is generally longer to let the tool down, that sort of thing. So that guy generally wins, and that's the height, like the distance away that the buffer will be. Now this super section thing, I was talking in the other video about it's nice to make 16 sections into one big block, but then the programming becomes a bit of a pain. And this is where you're going to kind of see where that programming is a pain. So the super section is the last section. Like if there were 3 sections, then the 4th section is the super section, meaning that everything is on. So all this is just going to be a bunch of cases, like a bunch of if statements. If something's wrong, then we want to turn that super section off because we can't control the sections of the super section. It's just like one big section, it's either on or it's off. Are we close to a headland? Are we close to a boundary? Because all those things affect whether or not that super section can be on or off. So we find out any buttons are on. Did somebody push a manual? Did someone turn one of the 16 sections off? Or is any of the sections outside the boundary? Remember, we calculated all that. Are any going backwards? The farthest look ahead. All these sorts of things we look, and we determine if any of these fail, then we turn the super section off. Otherwise, it's fairly simple because then it just becomes like a single section. Check if it's going backwards. If there's only one section, well, then the super section is the section, and we don't need that either. So we just turn it off. Or if our tool speed is really, really slow or below our cutoff speed, then we also don't need the super section on. If our right side's in a headland or the tool left side's in a headland and the headland is on, well, then we know that we're crossing the tool or we're crossing the headland. Therefore, some sections are going to be on, some sections are going to be off. Again, the tool is not allowed on. So then we picked our biggest one for the on height, like the section look ahead, or the tool lift look ahead. And what this does is a minimum pixel requirement. You can imagine that the super section will never shut off or it'll never turn on if it sees any pixels. So, because if it sees pixels coming up, it knows that a section is going to turn off. But that means if you're overlapping a little bit, that means the thing will never come on because you can see some pixels. So if you take like a quarter or a third of the edge of the section and you take the look ahead and you count up how many pixels that will be, that's how many pixels it has to exceed before it'll actually turn the super section off. So that's just kind of a safety. Otherwise, it would never turn on. All right, and then here we pick the biggest, tallest one. We limit. Again, we have 250 maximum amount of possibilities, so we're going to limit it to 240. And we don't want it smaller than 8 because then we don't want to run into dividing by 0 and that sort of thing. And now GL read pixels. It takes the tool position, how wide it is, starts at 250, the width of the tool, and the height that we calculated here based on the tool height or the look ahead. And we're only going to grab the green pixels. So this guy is the pixel buffer is 125,000. Otherwise, it would have been, what would it be? 375,000 bytes big. So this just saves it all by just doing it green, and we only want to record the green. Now normally, in order to make it visible, you have to uncomment these, make the BackBuffer current, and then swap the buffer so the user can see it. So you have to uncomment those. But we don't need to do that. We don't need to take that step because nobody's going to see it anyway. All right, total pix 0. Remember, that's that limit that we calculated up there. Now the real fun begins, and some variables for the slope of the line. So the first thing we do is, if there is a boundary, if there's no boundary, of course, then we're never going to see a boundary, so we don't have to do this. But the first thing we do is we have to look ahead and see if there is a boundary. And we do that down here. We look for that 240. If there's a boundary, turn the supersection off. Here we're looking ahead for applied pixels. You know, anywhere the pixel isn't 0 and the total pixels exceeded that number based on the width of the section, if that exceeds it, also turn that section off. That's all this stuff does, is it just says, hey, you know, there's a boundary close, sets that flag as true. And then the other thing that can be on or off is the headland. So we use the slope of our right side and our left side. We talked about that in another video over the tool width. That gives us the slope of the line. And we calculate that slope, and we figure out all the way along the section. Remember that little triangle thing we make if you're going around a corner, or if it's a box and you're going straight out. But the important part is that if we see a headland in that anywhere, that means the headland's close. And we're going to have to turn the supersection off again. And so then we have to decide whether or not we're going to turn the supersection off. But you'll notice that even though we see it, we don't actually turn the thing off or on, because it's not necessarily going to be off even though it's in the view, because you may or may not be in or out of, completely out of the headland. So that one's a little trickier. Only if, you know, the outer points in the headland and the headland is close, then you turn it off. So it's kind of like half in, half out. Then you turn the supersection off. And then based on that, depending on where you are, then we set the hydraulic position to be either up or down. And that's all that does. Okay, so that was checking the boundary, checking the applied, checking the headland. Are we half in the headland? Are we not half the headland? Are we possibly outside the headland, but a point of the headland is still in the view, that sort of thing. You have to check all of those different positions, because you can't just text a line in or out of the boundary, because the two outside points can be outside of the headland, even though you're still in the headland in the middle of it. So that's what was, again, a little tricky. So this else is for whether or not there was a boundary to begin with. If there's no boundary, that means there's no headland either. And it just becomes look for pixels ahead. So again, this one's much simpler. We don't have to look for the boundary. We don't have to look at the headland, that sort of thing. And then if we see too many of them, then it just shuts it off. If total pixels exceed the pic limit, then we shut the supersection off. And if we're all manual and all the manuals are on, well, we can also go supersection. If one of them is off, then we can't. So that's just a quick check to make sure that all of the sections are on. And even though it's manual, it's still okay to make a supersection. And now if this thing is allowed on, then we have to make sure and turn off all the individual sections and the mapping individual, because the supersection is its own section. So we have to shut all these other individual ones off and make sure that they're off. If they're mapping, or if they're on, turn them off. And you see here's an off request, an on request, an off timer, and an on timer. What these guys do is we'll be looking at a tool where we process section request and mapping request, where this sends a request. Just because we want the thing to be off doesn't necessarily mean it should be turned off, because remember there's the delays and the look aheads and all that other thing. So based on those settings, we have to send that we want the thing off, but don't necessarily turn it off until it's at the right time. If we want to turn the supersection on, then mapping request is on for the supersection, and off request, on and off request, depending. So that was it for the supersection being on. Really simple. You just turn the thing on. If it's all the criteria match for the supersection is on, well then you just turn it on, and the mapping. Pretty simple, because there's nothing around it, there's no switches off, whatever. Now if the supersection isn't on, then we need to turn it off. So kind of the opposite of what we just did by turning on or off the individual sections, we have to take all the individual ones and turn them off as well. So the off of the supersection gets requested, and the on request is false, and reset the timers. Great, now that's all off. So our supersection is off at this point. Remember, we're doing now, the supersection has failed, and it is false. We do not want it on. So now we're going to do individual section control. All right, end height and start height. That is like, remember we had the turn off line, and then we had the turn on line was ahead of it. When we have a start height and an end height, then we're trying to look what's between the off line and the on line. So now we're having kind of two slopes to look between. So it becomes a little more complicated, but you just start from the bottom line and you count up to the top line. And we look for the area in between. And so the mapping, what it does is it looks for any unapplied pixels ahead. If we see any unapplied pixels ahead, then we turn the thing on. If there aren't any pixels ahead and it's all applied, then we just turn it off. So here we default to off, and the only time it comes on, we get a mapping required is true, and then we want to turn the sections on. If it's all applied, then we just leave it at false. So mapping is fairly simple. If we're out of the boundary, now all kind of crazy conditions come again. There's a boundary and a boundary array, and our section isn't in the boundary, well then we want to actually have an off request, because even though there's unapplied pixels ahead, you want to turn that section off. So the mapping off request becomes true. Is it required on? No. And on request is false. Same with the headland area. If the section is in the headland area, like meaning outside of the headland line, and the headland is on, we also want to turn it off. So we're in the headland, and we don't want it on, even though there's unapplied ahead, so we have to make sure and turn it off. So that's kind of the conditions for mapping. You know, if there's nothing ahead, then turn it on, because it defaults to off. But if you're in these other conditions where they shouldn't be on, then you have to make sure and turn it off. All right, section control. Now again, we go through all the individual sections. Like if it's 16 sections, this goes through 16 times. And same sort of thing, we default to the sections off. If we're not inside, or if we're out of the boundary, then we turn the sections off, just shut them off. That's just simple. If we aren't outside the boundary, then the same sort of thing again. We look inside those lines and we try to find, is there unapplied pixels? And this is that minimum unapplied. Remember on the settings for the section, you enter that minimum applied pixels. What you're doing here is you're setting that, if you set it to 10, well then you have to see 10 blank pixels in that section look ahead before the section is required on. So if you set this to 0, as soon as it sees 1 pixel, it'll turn the section on and then jump out of this loop. So again, this is just looking ahead and finding out individual pixels. So that's all that minimum unapplied pixels does. You have to figure out a better way to call it. It's basically 10 centimeters by 10 centimeters. Remember, that's how big a pixel is of area. So if you had 10 of them, well then you're going to have 1 meter by 10 centimeter patch of land that isn't applied. That's how big of a chunk of land you need in order to turn the section on. Okay, so looking ahead, looking ahead straight at the tool, there's unapplied area. But now the trick is we're doing look ahead, turn off. So remember, there's the offline again and then the online. So we need to find out if between the offline and the online are completely applied. And if they are, we need to ignore the fact that just ahead of the tool is on, and we have to turn the thing off. But there's also, is the boundary close? And so there's some of the other conditions, again, those silly boundaries. we have to turn it off no matter what, or if you're coming in and out of a boundary, it still has to stay off. And so if all of those things are, let's back up here. Only if the section is required on do we need to turn it off. So then if it's required on, then we default to off. And then we look at the conditions of off delay, and if it still needs to be turned on, then we still put it back at true. And that's for turning on. But now if a headland is coming up, same sort of thing again. We have to figure out, is the tool inside the headland completely? Is it outside the headland completely? Are we in the headland? Are we in the work area? All that sort of thing. So we have to look, see there's that 250. We need to look ahead between the offline and the online. Is there a chunk of headland in that look ahead section? And then if there is, then we also have to determine, are we inside or are we outside of the headland? So that's where the look ahead of the section, those points now are figured out whether or not you're inside or outside the headland. And between the combination of them all, you can figure out, are we entering the headland or are we leaving the headland? Because if there's just headland there, you don't know what direction you're going. Are you going in and out of it? Are you going out of it? Are you going half out and then back in? Because you may not have even left the headland completely. So you have to figure out which direction are you entering or are you leaving the headland. So that's what the combination of these guys do, is they try to figure out between the points, are the points completely in the headland or not? So that's where, where are the tool look on points. And if any of them are in the headland or completely in the headland, then we know we can turn it off. But if any one of the points of the section are inside the headland, then we have to leave it on because we don't want to turn that section off. Even though everything may look like it should come off, it needs to stay on. So that's just the combination of looking in that look ahead area for a headland and finding one point inside that headland. Whew. Okay, the no boundary is pretty simple. This looks pretty simple now because all we're doing is we're looking for points ahead. If there are points ahead that are unapplied, again, if they exceed, then we turn it on. 0 is unapplied. And if they are applied, turn it off. That part's really simple. Okay, now we go through all so now we have, this is only half done now. What we have is a request, should the section be off or on? But now we have all the human interaction, the GUI part of it, and it's like, is the master control on? So then went through every one of these sections again. Is the section required on? Is the auto on? Is the manual on? Is it, so then is the thing required to be on? Is it required to be off? Is the manual on? Does it force it off and on? Do we just ignore everything that we just did because the manual is on one of the sections? So for each of these sections, and this is priority based, auto is the least priority, and then manual and the slow speed cutoff, that sort of thing, they are the highest priority because if you stop, the section shuts off. End of story. And it's the same for mapping. Is the mapping required on? Is this auto on? Is the manual on? That sort of thing. So that all becomes, the same sort of priority based. So you can see that the mapping and the section control are completely different, and they run their own show based on where the section is. Okay, and again, if the work switch is on and work switch is enabled, then turn them on or off accordingly. So he's got the absolute highest priority, is that work switch, because it just turns it off and on. Whew. Okay, process sections off and on. We'll go to that definition. Scooch this over. Okay, processing the sections off and on. Again, for every section, remember we had those section on and off requests. So if there's an on request, turn it on. Simple. We just want the section on. Just bam, turn the section on. The off request is a little tougher because we have look ahead off and we have delay off. So we set the off timer based on our turn off delay and our update frequency, that sort of thing. And depending on whether or not the section request is off or on, and we get an off request, then the timer counts down based on our setting. And then if the counter is 0 and we have an off request, then we turn it back on. If it has a requirement to turn back on, it'll just kick it back on, and then it'll just increase its off timer back up again. And mapping is very much the same way. If the mapping on request is on, we just turn the mapping on. And turning it off is a little trickier because you just want it just to cross the line no matter how fast you're going. So we shut it off based on kind of a exponential function of speed. And also, if the turn off delay is on, then we want to include that time in leaving the section on so that while the sections are on, it continues to map, even though we broke all the rules and it's, there's no unapplied pixels, but the section's still on, but we still need to map. But we need to calculate this independently because because again, they're not linked. The section and mapping are running their own show. So this goes through and does all the sections, and it turns the mapping and the section on, off or on. And then that comes back to the OpenGL again. And then now we build our machinery byte, where we take those individual sections and we mush them all together, and we send it out to machine port. And voila, your sections turn on and turn off. And then we go through and then, do we need to save the files? Is it a minute counter? Is it a 10-minute counter? Do we need to check if we need to, go into night mode, that sort of thing? And then the thing is done. And 100 milliseconds later, it does it all again. And again, and again, and again. So that was just the sections. That's a small part of the program, but it's fairly complicated. And I hope you have a bit of understanding what's going on with the sections and all the different possibilities of what can go wrong. In terms of turning it off, turning it on, in and out of boundaries, in and out of headlands, position, speed, going backwards, going forward, stopped, manual switches, auto switches, all of those combinations. And in the end, all you really want to know, do I need to turn a section on? But it's a lot of logic before you get to that simple answer. So there you go. Pretty simple. Anyway, thanks guys.